Okay, up on the bench today you can see we have a something extremely rare, a brand new in the box, new old stock Cherokee Nightrider 150. This is a 40 channel AM sideband mobile radio. They're kind of rare in themselves, just what it is, but it's even rarer that it's, like I say, brand new in the box. So I guess that kind of gives its age away a little bit. Yeah, free 30-minute phone card inside. Yeah, back when freebie phone cards were the thing. So let's crack this box open here and see what we got. So the customer sent this in once all of the electrolytic capacitors replaced and a transceiver alignment done, and that's it. So he wants to be able to use this. And even though its new old stock has never been used, it still is, you have to remember that middle letter in NOS, old. So there's our owner's manual. Mounting bracket. Should be the accessories, mic and power cord, yeah. And then here's our radio. Let me get this cardboard box out of the way. Let's put it back in here. Won't be needing any of this. And yes, sure enough, we have a new old stock. Ooh, this would help have it up there so you can see it. Cherokee Nightrider 150. And being brand new, it is in absolutely mint new condition. And look at that. There's our Cherokee Nightrider 30-minute prepaid phone card. So they even went to the expense of having custom phone cards printed for them. So let me get the cover popped off of this really quick so I can give you a peek of the inside before I actually do any work. So I'll be just a second. Okay, so here you can see we're now inside the radio. Should look very familiar. It's the layout is basically the same as dozens and dozens of other radios, but they did do a few things in these a little bit differently. For starters, they're using a PLL chip that is not, when this radio was made, FCC licensed radios, because you have to remember this thing does have an FCC ID number. So this is a legal CB radio. This is not an illegal what I call black box export radio. So there's two circuit boards here. On the bottom circuit board, all that's hanging off of the channel selector there, is the PLL chip. Now, the PLL chip that's in there is what the hell is that? 14506, I think it is. I'd have to pull the schematic and look it up. But at the time this radio was made, manufacturers are not allowed to use that chip anymore because it's too easy to modify for extra channels. But you'll notice it is a legal radio because it does have an FCC ID number. So how did they get around that? Well, with the either they just did it on their own, or the FCC told them they needed to do it to get a license for it. Was they had to make it basically impossible to do a channel modification on this. So if you were to separate these two boards, the PLL chip is encased in a block of epoxy. So that was their way of being able to get type acceptance from the FCC, was to encase the PLL, that basically illegal PLL chip in a block of epoxy so it could no longer be reached. So otherwise, like I say, it's fairly standard layout. If you notice this little funky cable here, that's for the backlight. This has a backlight illumination, so this is what controls that and goes up to that photoluminescent strip there. So that's actually that flat ribbon cable there goes up to that photoluminescent strip. But like I say, you can see the layout. It's just your fairly standard. So doing alignments on these, pretty much everything else, repairs, it's just like doing it on any other radio like this, because you can see the layout's exactly the same, all your alignment points, same crystal filters, has the, you know, the later versions, smaller ones, so it's not big like the old radios had. But nice little radio. So we'll get the electrolytic capacitors replaced and do the alignment on this, and we'll see what kind of performance this little thing has, you know, especially like receive sensitivity. I hadn't really planned on showing you the radio torn apart. I was just going to show you what it looked like new and what it looked like when I'm done with it, but I thought, well, I got to pull it apart, so I might as well just go into a little bit more detail with this radio and some of the kind of unique features. Now, I pulled these two modules, just makes working on them easier for starters, because I got to replace the electrolytic capacitors. So this is the module for the electroluminescent display, or the backlighting. And then this is a compander module, which I'll get into in a minute. Now the reason I had the faceplate torn off is because you can see there's two electrolytic capacitors right here. The only way to get to those is to dismantle the entire front of the radio so you can get up in from the underside to get to them, because when the radio's together, there's no way to get in there to desolder them and solder new ones in. So that's why the entire faceplate had to be taken apart and this, you know, all this removed so it could be pulled up and out. And I don't have to remove it any farther than that, but that's why it's, you know. But since we have it like that, I can actually show you the PLL synthesizer module somewhat. You can actually see it a little bit now down in there. You can see everything's encased in black epoxy. So that's how they got around using a chip they weren't really supposed to be using for a PLL, but the FCC let them slide it through as long as they made it impossible to get to, so it's completely encased in epoxy. A couple other kind of unique things to this was reverse protection diode. Pretty much all mobile radios have them. Now a diode conducts in one direction and not in the other, and they're installed backwards. That's why they're called reverse protection diodes. So normally when you hook up your power cord, they don't do anything. But if you accidentally hook up a power cord backwards, they're designed to be basically a dead short. Your power wire sees a dead short, and the idea being it'll blow the fuse instead of your radio going up in smoke. Normally they're just mounted down on the circuit board where the power comes in down here. They didn't do that on these, and got to remember, it's a legal FCC radio, so it's not like it's one of those high power illegal export radios. So it only has a single final. But usually those diodes in a single final radio are fairly small. Not in this radio. They used a big honking reverse protection diode back in there, and then on top of that they even mounted it with a little aluminum brackets wrapped around it, mounted to the rear of the chassis. Kind of unique. Another thing, the driver transistor is mounted to the rear of the chassis. The final, however, is mounted to this other bracket that's at an angle, so the final transistor is actually cocked forward at an angle about like this. It's not standing straight up and down. I'm not honestly sure why they did that, other than to add a little bit more aluminum mass there for better cooling, but they did. Now one thing that is really kind of unique to these is the bias diodes. They're housed in these little plastic covers. They're kind of hard to see down in there. If you look down in at the driver, you see you can't even see the driver transistor. You see a little orange speck in the middle there? That's actually the bias diode you're looking at through that plastic cover that's over top, and that holds the bias diode directly against the face of the transistor, so it can, you know, very accurately get, you know, change its conductivity based on the temperature of that transistor. But yeah, it's another thing that's kind of unique to these, is those little plastic. Actually, if I remove the mirror board, you can see down in there a little bit better, but you see how that's at an angle. It has that little plastic cover over top of it. So another thing, it's kind of unique. Like I say, this is the module for the electroluminescent display. So that just has a, once you get all the knobs and everything taken so you can get this off, you can see this is just a flat ribbon cable, okay, with a little bit of copper exposed there on the end. And then that just plugs into that plug on the end, and then there's the other plug there, like I say. So I got to change the caps on that. It's nice, everything just plugs in. Now, this could probably best be compared to probably like the Cobra sound tracker system somewhat. In this radio, they trademarked the name Clear Drive. And if you look actually on this faceplate, you'll see there is a CD position, off or CD. That turns this module on and off. And they call this the Compander module. So basically all this is a compressor and an expander. So we look down here at the two plugs, okay? You'll see there's a little coax cable. Your mic audio actually goes to this board. And when you turn the switch on and off, that actually is either turning this module on or off. When it's off, your receive is normal, your transmit audio is normal, just like any other radio basically. But when you turn that on, it turns on the compressor. Now the compressor is only used on the transmit circuit, and that's your voice audio actually. So that comes into this module, and it compresses it. And what a compressor does is, so when you're talking, like I am right now, there's going to be, if you were to look at that on an oscilloscope, you'd see, or even a audio spectrum analyzer, you'd see there's going to be peaks and signals that are really high in amplitude and ones that are really low. What a compressor does is it basically clips or reduces the high level and increases the low level to try and even them out. The idea being to try and have more transmit audio power. Now this is most evident when you're in transmit mode, or when you're in sideband mode. That's where you really can take advantage of a compressor that really shines in sideband. But like I said, basically all it's doing, it's lowering the level of the high level signals and increasing the level of your low level audio signals to try and even them out a little bit more. Now, the expander works in the transmit circuit and only the transmit circuit. So it basically does the exact opposite of what a compressor does. The expander module reduces the gain of low-level signals. Yes, I said it reduces the level, does not increase them. It reduces the level of low-level signals and increases the level of high-level signals. The idea being there is, if you have a signal that you can barely hear to start with, it's basically nothing more than background noise. So it's actually taking away from the clarity of trying to talk to somebody. So it reduces the low-level noise then, and the high-level signals, which is the stuff you're going to be, probably the person you're talking to, it actually increases that signal level. It gives it a boost even more. So, you'll notice loud signals are even a little bit louder, but the noise floor will drop out. You'll get a lot less background noise with the expander. So that's a nice little feature. Like I say, they call that the Compander mod. That's what they called this module, was the Compander module. So that's what that is and what it does. So I can now that I've explained some of the little unique things about this, I can actually get into doing the cap job on it. Okay, just really want to quick. I got the alignment has been done on this. Of course, the faceplates you can see still removed. The power supply module for the electroluminescent faceplate display is removed. That I just left all that out so I could actually get in to do the alignment back here. But I wanted to show, I do have the Compander, what they call a Compander module, which is a compression and expander module. What that does for receive. So I got a little bit of skip rolling in, so I figured, Christ, turn the radio on really quick. So you can hear that noise. There's not a lot of noise there. Now the expander is on. Now remember, the expander reduces low-level noise and increases high levels. So the more powerful the signal that comes into the radio, it boosts it even more. The lower the noise gets, the more it cuts that out. The idea being it cuts out stuff that you really can't hear anyhow and boosts the stuff that you do want to hear. So you can hear if you can hear a little bit of static there in the background, and I'll listen to what it sounds like when I turn that module off. And if someone would just happen to come back on and start talking again, as there was on there a minute ago. Yeah, it figures. The skip rolled in and the skip rolled right back out. I was getting Florida there for a minute. But like I say, it doesn't really affect so much. They say it boosts it. Honestly, I don't really notice that much of a boost in audio for the the transmission you do want to hear. But for the noise floor, man, it cleans it up so much. Just does wonders for reception, especially on sideband. Now that works on sideband and AM. So let's flip back to AM. See if there's anything on the Super Bowl. Okay, there's somebody. So there it's off. On. Off. On. Notice there's no difference. So you can hear it really cuts out the noise floor, but doesn't really affect the signal you do want to hear. Like I say, they say it does boost it a little bit. It may, but not that much. Like I say, it's very good at reducing the noise floor and a lot of wash and whatnot, so really nice little module. I might actually have to start making those things, to tell you the truth. That one really works well, and that one actually has a lot, compared to the Cherokee, what is that, the CBS 20, God, I can't even remember anymore, is that 2100? That had a compander module in it too, but I actually looked at the schematic, because there's no published schematic for this board, in this radio. There is one published for the CBS 2100. A lot of different values. I mean, it's just, I'm not going to say it's a completely different circuit, but it's drastically, the values of a lot of the components in here are drastically different. And this one actually has a few components that one doesn't. It uses the same chip. But, yes, I might actually draw the schematic out for that and see about prototyping one and trying that in a few other radios. You know, stick it in a, like a Cobra 148 or a, 2000 GTL, try sticking it in, which actually they don't, it's not that they need it that much. They're, the older radios had good receive, but the newer radios, these Rangers and Galaxies nowadays, oh my God, they're just horrible. That little critter right there just might do wonders for getting rid of a lot of that unwanted noise that those things have. So, like I say, I might actually have to tinker with making up one of them. And here's all the, because this thing does have a lot of them, a lot of electrolytic capacitors. You can see how many there are there. It's got a boatload of them. Some of them try to roll off the bench. But that's because it has so many more on that compander module and the power supply board for the electroluminescent display. So next thing we'll do, we'll get her put back together and hook it up to some test equipment and see what receive is like. So the actual true receive sensitivity, take some measurements. Okay, so the Cherokee Nightrider 150 is now back together completely. The only thing it had done was its electrolytic capacitors replaced, and it had a transceiver alignment. Now you had not seen this, I don't think, on with the faceplate yet. So this has the electroluminescent faceplate, but that little power supply module was back here in the corner. Well, actually now that it's right side up, it would be over here. But you can change the intensity. So right now it's dim. You can see there's a little bit of a glow there. But when you turn that up, now it may look white there, but as soon as you get any type of, in the darkness, so like let's say at night, you can see it's a nice, pretty light blue. But actually looks really nice. So let's do some receiver test on this and see just how well it picks up. Now you have to remember, this is a more modern style chassis. So, much like Rangers, the newer Cobra 148s, all those types of radios that have the smaller crystal filters. I was actually surprised. Actually, the receive sensitivity on this is actually better than a lot of the more modern radios, even though it's running basically the same chassis. So I have it hooked up to the communications test set back there. It's currently in lower sideband, channel 19, so it's being fed a 0.11 microvolt signal. I have the speaker hooked up externally into that. Let me turn the volume up. And what we're looking for is a minimum 12 dB synad measurement with the lowest signal level. So looks like right around 0.11 excuse me, 0.11 microvolts, or minus 126.2 dBm. Yeah, I'll go say maybe drop it down just a hair. Yeah, I'd call that one right around 0.11. So let's switch to AM. Around 0.42, 43 maybe. We'll call that one right around minus 114.3 dBm, or 0.43 microvolts. So has good reception on AM and sideband. Like I say, actually a little bit better than most of the radios that run this style of chassis. Actually listening on air, this is the feature that's really, really nice about this radio. That compression expander. The compression really helps with transmit power. Honestly, with this radio, the stock mic's probably honestly all you need. You really don't need a power mic with this if you turn that on. You turn that on, I'm here to tell you, it's a power mic. You're going to, like this microphone right here, you almost need to turn it down to like 1 or 2 with that turned on, because man, it can I've got an air conditioner running 2 rooms away, and that noise is enough to get a little bit of modulation when I have that turned on. If I have this turned up to its the level where I'd normally have it set, so yeah, it really makes the microphone sensitive. But like I say, that's what it's designed to do. The clipper, or the compression circuit, lowers high levels and then increases lower levels. So it evens out the audio, basically the audio volume level on your transmit, so you have more punch. And like I say, that's very noticeable in sideband. Then in receive, that's where the expander comes in. That increases, it actually boosts high-level signals, so the actual voice transmission that you're listening to, and then it reduces low-level, which is normally going to be your noise floor, all the noise, which you don't want to hear anyhow. So it pretty much eliminates that. You heard that earlier when I had it turned on. It all but eliminates that noise. It takes a noisy receiver and it puts a clamp on it. Worked really, really well. So there you go. There is a new old stock Cherokee Nightrider 150. I think the customer will be very happy using this, because like I say, I was rather impressed. Has good sensitivity for the more modern chassis, and that switch right there would probably never leave that position. I'd probably leave that on 100% of the time, because man, it just sounds so much better with that expander turned on.